Hi there and welcome to Uckers.com. If you're watching this video, you probably already know the fundamentals of this great game, but are interested in learning how to improve and win more games and dish out those monumental 8 pieces that we love. The first stage of playing better Uckers is to understand and know how to use dice probability. In this brief video, we're going to explain how dice probability is calculated, why it's important, and how you can use it to your advantage. Before we start though, why not hit that like button and subscribe to our other videos? It will help us spread the word and increase the popularity of the game. Okay, let me go through now dice probability.
In this short video, I'm going to explain the importance of understanding dice probability and how it can improve your overall Uckers skills. Similar to understanding the odds of drawing cards at the poker table, your Uckers game can be improved by knowing the odds of either you or your opponent throwing specific numbers. There are two different ways to consider the outcomes of dice when playing Uckers. First, we'll focus on the chance of throwing a specific number on 2 dice. It's useful to know, for instance, if you need to throw a 6. Obviously, this covers all the numbers on the dice. To calculate probabilities, we need to know the number of desired outcomes and divide it by the number of possible outcomes. For example, the odds of rolling a 1, or any other number for that matter, with a single die is calculated as follows. The number of desired outcomes here is 1, as there is only one number 1 on the standard die. The number of possible outcomes is 6, as there are 6 numbers on the standard die. Dividing the number of desired outcomes by the number of possible outcomes gives us 1/6 for both dice. Because we're looking at the chances of rolling a specific number with 2 dice, we add these together. This equals 2/6, or, when reduced to its common denominator, 1/3. If we multiply this by 100 to give us a percentage, it gives us a 33.3% chance of rolling a specific number with the 2 dice for all numbers between 1 and 6. The second calculation we need to understand is the chance of rolling a specific number through the addition of the dice. Here we can't throw just a 1 with 2 dice, and so it sits outside of our calculations. All other numbers, though, follow the same formula to work out the probability. However, to get to the actual probability of a combination of the dice, it has a slight difference in the way that it's applied. I'll walk through that now. Because we are using 2 dice and are looking for the probability of throwing a number through the combination of these dice, the number of desired outcomes changes from 6 to 36. Let me explain why. If we want to throw snake eyes, for instance, double 1, we take the probability of throwing a 1 on each die, namely 1/6, and then we multiply the fractions together instead of adding them. This gives us 1/6 times 1/6. 1 times 1 is 1, 6 times 6 is 36. Divide 1 by 36 and we get 0.027 reoccurring. If we multiply that by 100 to give us a percentage, it equals 2.78%. Now let's look at another number as an example. Here we are considering the probability of throwing 9 with 2 dice. As you can see here, there are 4 possible combinations, 6-3 and 5-4, with both combinations reversed on the dice to give us the 4 possible outcomes. The formula is the number of desired outcomes divided by the number of possible outcomes. With 2 dice, there are always 36 possible outcomes, 6 multiplied by 6. So we have 4 desired outcomes over 36 possible outcomes, which equals 0.11 recurring, or when multiplied by 100 to give us a percentage, 11.1%. Okay, let's look at another number. To throw 2 dice, which produces the value of 6, you can see we have the following possible combinations: 1-5, 5-1, 2-4, 4-2, and 3-3. Referring back to our probability formula of number of desired outcomes divided by the number of possible outcomes, we can see that we have 5 possible desired outcomes and, as always with a pair of dice, 36 possible outcomes. Doing the division gives us 0.139 or 13.9%. As a final example, to throw 2 dice that produces the value of 7 gives 6 possible options: 6-1, 5-2 and 4-3, with the values reversed on both dice. This gives us 6 desired outcomes over the standard 36 possible outcomes. As a percentage, this has a 16.7% chance of occurring. Okay, so let's bring these two variables together and start by recapping on the chances of rolling a specific number on the dice with 2 dice being thrown. You'll remember that we calculated this to be a 33% chance. This forms the basis of overall dice probability. The chances of rolling a number with the value of 2 dice combined has variable probabilities depending on the number. We've already covered a couple of these through the examples that we've gone through. This graph shows the percentage probability for each number from 1 to 12, bearing in mind that 1 is not a valid outcome. You can see that we are much more likely to throw 2 dice with the value of 7 than any other number. If we add the two conditions together, we get this graph showing the possibility of throwing a particular number in blue and a number resulting from the addition of 2 dice in orange. Bringing the two graphs together gives us these values. The question now is just how do we use this knowledge? Well, if we are looking to make a blob or hack an opponent's counter, for instance, it is useful to know the probability of throwing the necessary value on 1 dice or the combination of 2 in order to judge the potential success of what we're trying to achieve. Why don't we go to a board for a real-life example? I'm sure those of you who have played the game a few times will be familiar with this situation. We're playing red and yellow and have a blob that has been holding up our opponent. We have our other pieces either in the base or safely home, so without a 6 we are short on options. With no other pieces available to move, we find ourselves in a dilemma about how to break up the blob when we throw the dice and don't get a 6 or a double. We've thrown 5-4, so the two options we have are to move one counter 9 spaces or one counter 5 and the other 4. What should we do? Let's look at the probabilities if we move both counters. One 4 squares, the other 5. If we remind ourselves of the probabilities of our opponent hacking our counters, we can see the following. Our opponent will need to throw 5 or 6 individually or through the value of the 2 dice in order to hack off one of our counters. Referring to our table of probabilities, we can see that the odds of them getting one of the counters is very high. So now let's look at the other option, where we move one counter 9 spaces. Our opponent can hack us off if they throw a 1 or if they throw 10. The probability of throwing 1 with 2 dice is a third, and for throwing dice which equals 10 is 8.3%. Together, this has a much less chance of happening than the previous option and should be the better choice.
We hope that this goes some way to improving your game and that you'll own your skills further in ranking games on Uckers.com. We'll put together more videos on how to use tactics and strategies designed to improve your win rate and your overall scores. As we develop, we'll be introducing online leagues and tournaments, so get learning and preparing for some real challenging Uckers games. Whatever you do though, we really hope you enjoy Uckers.com. May your blobs never be mixed.